Thank you, Mireille. I'm going to present myself. I'm Olivier Martimort from Nanosense in France. And I'm going to show you what we are doing in our company, which is very dedicated to air quality. We do indoor mainly and some outdoor probes. And on the left, you can see our main product, which is the E4000NG, which has CO2, VOC, temperature, humidity, and have some temperature control, ventilation control, and over-the-cable update firmware. On the middle, you have the particle probe, P4000NG. And on the right side, this is a flush mount product. Others were wall mounted. And with 12 measurements on board, and also, of course, the control algorithm on board. All of them, as you can see, have many protocols. And this is recap here, where multi-sensors, multi-protocol, multi-criteria of remediation, of course. And they are all designed for 10 years lifespan. This is required by KNX, by the way. And this is really designed for maintainability. So most of the sensors are plug and play. We can even identify, in case of failure, the part that has a failure with a built-in test. And the MTBF for this probe on the right is 42 years. This is, of course, designed for life cycle cost. As you can see on the bottom, it is quite modular, so you can plug a radio module, which can be either a Nanosense or LoRa. This is exactly the same kind of module. And of course, for the LoRa, you can see the data matrix that you can scan, as well as a join LED. So this probe, or those probes, are quite known, I would say, because we won the 2 Air Lab challenge of the micro sensors challenge in 18 and 19. They were now in 20. And as you can see, the result is that we are quite balanced between relevance, cost, ergonomy, accuracy, and so on. The choice of the radio that we had for our probes is that we decide not to use the Wi-Fi because it's forbidden in a French school, and also it's not as reliable as that we would like. So of course we have a Nanosense for building automation, and even if we, for some monitoring, give up this solution for long range, and we decide not to use the Sigfox because there is no downlink and not capability of a private network. And we, of course, have the LoRa, which is also allowed in French schools. It has been validated by various POC. And the big advantage is that we can use a private network. And if you want to speed up the transmission rate. And of course, it requires 1 gateway per building instead of many for a Nanosense. And here you can see an architecture of one of our POC. So this is in a school. On the left, you have the 2 probes that you have seen previously with CO2, VOC, temperature, humidity, and particles. And as you can see, one is controlling a VAV, a variable air volume, or register, to control the ventilation. And outdoor, we have a probe also that we do, which is also LoRa. And I want especially to mention that air quality probe is measured, the air quality, is measured every 5 minutes and sent every 10 minutes in a telegram where we contain the 4 measurements. So even if this is an architecture for operated LoRaWAN network, we are allowed to have a higher rate that's what is allowed in the transmission rate in terms of measurement. The drawback here is that we don't have any OTA because we have very few downlink. So update of firmware is impossible, which is not the case of the next architecture here, where we use a private LoRaWAN network, where we are allowed to increase the speed of the transmission and also benefit from the OTA, which is brand new now in the LoRa Alliance. The only drawback is that it requires an internet access or a 4G router, which is not always easy to get the internet access. Here I would like to highlight the interest of monitoring indoor air quality. On the left, you see the outdoor particles, which have been quite high recently, outdoor, but indoor, it goes through the filters, as you can see. Even if it is filtered, it's not 100% removed. Some pass through, and this is PM2.5 here. So this is just interesting to know how a building reacts and the ventilation system reacts to the outdoor air. On the right side, you can see in the center the VOC that increased during the night because this building, they shut down the ventilation during the night. So material are emitting and the VOC goes up. And then when the HVAC returns to on in the morning, it is evacuated and it is normal and acceptable in green. What we have on the bottom is the CO2, especially during the pandemic here, where we have a higher ventilation rate to try to reach an acceptable level of CO2, which is safe. But as you can see here, the peak are of course based on occupancy, but as you can see, we have the humidity, which is too dry, always because in winters, when you heat the outdoor air, that dry it because it is a relative humidity. So, to make a recap, the goals of most of the POCs that we have done were made in schools, and to guarantee a good air quality and to take into account the feedback of the educational community, based especially on what we can show. Otherwise, because there is no feeling of air quality, you don't smell it really, so it's not easy to appreciate it and to give feedback if you don't have any way of showing the air quality. So that's also allowed to ensure good monitoring and acquire good knowledge for mass deployment. So the return of experience is that we had to set up the CO2 level at 800 ppm instead of 1000, which is the regular one for the COVID. And this is why it is important to have the OTC or OTA I was mentioning as well. And for building where there is no HVAC, it has been shown that it is very important to have a very dynamic LED to open the window just in time and to close it, especially in winter time when it's cold, in appropriate time. So it has to be quite dynamic, and probes that are battery powered are not doesn't have such high rate of measurement. Also, very important point is that LoRa, even in operated LoRa, we can benefit from the downlink. Sorry, the downlink provides a change. We can change the measurement rate, so that means that we can slow it down during the night and increase it during the occupancy time, which is good to see also how it reacts, and especially for when opening a windows. If if the CO2 is evacuated rapidly or not. You need a high rate of measurement.